Students, today we will be studying the chapter Metallurgy, which is your chapter 8 in the textbook. In the beginning, we shall study about the physical and chemical properties of metals and non-metals. We know that the substances that are around us are either elements or they are compounds. The elements are further classified as metals, non-metals and metalloids. We shall be studying more about metals and non-metals, their properties, physical as well as chemical. First of all, we shall be studying about the physical properties. Physical properties means those which we can perceive with our senses, those properties that can be seen. The first property is that the metals are lustrous. That means they are shiny, they sparkle, but non-metals are dull. Metals are good conductors of heat as well as electricity, whereas non-metals are poor conductors of heat and electricity. That is the reason why we use electrical wires are made up of copper, aluminium, because metals are good conductors. Metals have got a high melting point and non-metals usually have a lower melting point. The density of metals is quite high, means the molecules and atoms are very closely packed. The molecules and atoms in non-metals are not so closely packed. Metals are malleable, that means they can be beaten into sheets. यानी हम उनको ठोक के उनके sheets बना सकते हैं, उनको bend भी कर सकते हैं. But we cannot make sheets out of non-metals because non-metals are brittle. And if you try to beat them, they will break into pieces. They will get powdered, but there won't be a sheet. Metals are ductile and you can make wires. You can draw them into wires. Non-metals are non-ductile. Metals are usually solids at room temperature. Non-metals are solids or gases usually. But there are a few non-metals which are liquids at the room temperature. Remember that we are talking about at room temperature. The metals are opaque as a thin sheet. Opaque means light does not pass through them. But non-metals, they are transparent as a thin sheet. Metals are sonorous, means if you beat them, they produce a ringing sound, like the tongue sound you hear in the bell. That is the reason why temple bells are made up of metals. But non-metals are not sonorous. If you hit them, if you beat, you can't make a bell out of wood because they are not sonorous. So these are the physical properties of metals and non-metals. But there are certain exceptions. Metals such as mercury and gallium exist in the liquid state at room temperature. Now we had done that metals are usually solid at room temperature. So we have two metals which are existing in the liquid state at room temperature. Now in the case of non-metals, I said that they were usually solids or gases. But we have one non-metal, that is bromine, which exists in the liquid state. This is extremely important. Generally all metals are hard. However, the alkali metals from group 1 in your periodic table, such as lithium, sodium, potassium, you know, lithium, sodium, potassium, rubidium, cesium, francium, they all fall in the group 1 of the periodic table. These metals are called alkali metals and they are extremely soft. They are so soft that you can cut them with the knife. The tungsten metal has the highest melting point. We studied that metals have got a high melting point. And you can see tungsten has a really high melting point, 3422 degrees Celsius. But the melting points of metals such as sodium, potassium, mercury, gallium are very low. Let us see the exceptions in non-metals. We studied that the non-metals are dull. How are they? Dull. But iodine is the exception. Its crystals are shiny. Diamond, which is an allotrope of carbon, it's a non-metal, but diamond is the hardest natural substance. We know that non-metals are usually soft. They are not hard. Graphite, which is an allotrope of carbon, is an exception as it is a good conductor of electricity. Normally, the non-metals are bad conductors. How are the non-metals? They are bad conductors. But graphite is an allotrope of carbon, which is an exception, and it is a good conductor of electricity. Let us now start with the chemical properties of metals. We have already studied about the physical properties. Now we will study about the chemical properties. Metals are normally reactive and they lose electrons easily and they become positively charged ions. Like for example, if you see the sodium is 2,8, 1. In the outermost orbit, there is 1 electron which it can give away easily. It is not so tightly held and it can lose its electron. So when it loses its electron, it becomes a sodium ion and the electronic configuration becomes 2,8. Because it is forming a positive ion, so we call them as electropositive. So metals are called electropositive elements because they can form positively charged ions. Let us study about the reaction of metals with oxygen first. Metals combine with oxygen. They combine with oxygen to form metal oxides. Metals combine with oxygen on heating in air and metal oxides are formed. But there are certain metals which need not be heated to combine with oxygen, like sodium. Sodium and potassium, they are highly reactive elements. They are very reactive metals. Sodium metal combines with oxygen in the air even at room temperature. Understand that they can combine even at the room temperature and they form sodium oxide. So this is the metal, Na is the metal and it is combining with oxygen and what is forming? Sodium oxide. Sodium oxide, that is metal oxide. So now what happens when metals combine with oxygen? They form metal oxides. On exposure to air, sodium readily catches fire. Therefore, to prevent accidents in a laboratory or elsewhere, you keep it in kerosene. What happens is that what you do is that the kerosene, it has to be kept dipped inside kerosene. The contact with air is broken because it is dipped in kerosene. So, because what we had studied, that on exposure to air, it catches fire. Now, is there any exposure to air? There is no exposure to air. And so, accidents can be prevented. Oxides of some metals are soluble in water and they react with water to form alkali. For example, sodium oxide, it reacts with water and it forms sodium hydroxide. So, that's an alkali. So, what is an alkali? The oxides of metals that are soluble in water. Oxides of metals soluble in water are called alkalis. We know that magnesium oxide is formed on burning a magnesium ribbon in air. You must have noticed that a magnesium ribbon, if you take a magnesium ribbon, it is not blue actually, and you burn it, so it starts burning and it forms white powder of magnesium oxide. This magnesium oxide, if I dissolve it in water, it forms magnesium hydroxide. So that means magnesium hydroxide is an alkali. What is magnesium hydroxide? It's an alkali. Okay, so now let us move ahead. Let us now understand the reaction of metals with water. Sodium and potassium metals, as we already know, are highly reactive and they react rapidly and vigorously with water. They liberate the hydrogen gas during their reaction. You can clearly see in this picture that the sodium metal, Na stands for sodium. Sodium metal, it reacts vigorously with water. It liberates hydrogen gas, and hydrogen gas immediately catches fire because tremendous heat is also liberated in this reaction. It is an exothermic reaction. You can see over here that sodium metal reacts with water in the liquid state. See here, it's liquid, and what we get is sodium hydroxide, and hydrogen gas is liberated. As heat is liberated in this reaction, it's an exothermic reaction. Similarly, potassium also reacts with water and forms potassium hydroxide, and hydrogen gas is liberated along with a lot of heat. Now, in the case of calcium, calcium reacts with water slowly and less vigorously. The hydrogen gas released in this reaction collects on the surface of the metal in the form of bubbles. You can see in this reaction, this is the calcium metal, and these bubbles are sticking to this calcium metal. You can see the bubbles are being formed and they are sticking on this calcium. So these bubbles, they help the calcium metal to float. Calcium, when it reacts with water, that's H2O, forms calcium hydroxide, that's CaOH twice, aqueous, plus hydrogen gas. So we can clearly see that in each of the cases, hydrogen gas is always liberated. So when metals are reacting with water, what is formed? First of all, the metal hydroxide is formed, and hydrogen gas is liberated. The metals aluminium, iron and zinc now do not react with cold or hot water. So what did we see? Sodium and potassium, they react with water. Calcium reacts with water slowly and less vigorously, but they are reacting with water. But aluminium, iron and zinc, they do not react with cold or hot water. They react with steam to form their oxides. Now again you can see that what are formed? Oxides and not hydroxides. Hydrogen gas is released in this reaction. Aluminium reacting with water, what is formed? Aluminium oxide and hydrogen gas. Iron reacts with water to form iron oxide and hydrogen gas. Zinc reacts with water to form zinc oxide and hydrogen gas. So here we will see that metal reacts with water. These three metals, when they react with water, metal oxide is formed and not metal hydroxide. Now let us understand the reaction of metals with acids. In your textbook it is written, I suppose it is written oxygen, but it should be acids. Now, are all the metals equally reactive? They are not. You will see that these are highly reactive, and as we go down, the reactivity goes on decreasing. When magnesium, aluminium, iron, zinc, when they react with hydrochloric acid, then their chloride salts are formed. What are these? These are all chloride salts. Magnesium chloride, aluminium chloride, iron chloride, you can say ferrous chloride, zinc chloride. And if the metals, they react with sulfuric acid, that is H2SO4, then the sulfate salts are formed. What are formed? Sulfate salts. Now in both the reactions, hydrogen gas is always liberated. Let us now understand the reaction of metals with nitric acid. Obviously with nitric acid we'll get nitrate salts, but the difference with the above reactions is that hydrogen gas is not liberated in this reaction. In this, the gas that is liberated is an oxide of nitrogen. It might be N2O, NO or NO2. The oxide that is formed depends upon the concentration of the nitric acid. Now over here you can see that copper is reacting with concentrated nitric acid, and when it is reacting with concentrated nitric acid, NO2 is formed, that's nitrogen dioxide. When copper reacts with dilute nitric acid, now see here it's dilute, so nitrogen oxide is formed. So here there is NO2 with concentrated nitric acid and NO with dilute nitric acid. So we have completed the reaction of metals with nitric acid. Let us understand what the reactivity series of metals is. We already know that the reactivity of all metals is not the same. But which metal is more reactive, which is less reactive, we cannot determine with the help of the reactions with oxygen, water and acids, which we studied before. So how do we determine which metal is more reactive? So for that we require the displacement reaction. You already studied that a metal which has got more reactivity, it displaces a metal with less reactivity in a displacement reaction. You can see over here that sodium, which is more reactive, it displaces lithium, which is less reactive, to form sodium chloride. Now, if I had an element which was less reactive than lithium, it would not be able to displace lithium from the salt. So, this helps us in determining which of them is more reactive. If sodium displaces lithium, then sodium is more reactive than lithium. So, displacement reaction helps in determining which metal is more reactive. Accordingly, we have divided the metals into three different types of metals. The highly reactive metals means sodium, potassium, lithium, calcium. Then the moderately reactive metals, that is magnesium, aluminium, zinc, iron, tin, lead. And the less reactive metals, that is copper, mercury, silver, gold. Gold is the least reactive metal. You know, its reactivity is so less that we make ornaments out of them and we can wear them on our body. They don't react with water, they don't react with air. If gold would react with water or air, we wouldn't have been able to make ornaments out of gold. Now we will be doing the last reaction of metals, the reaction of metals with non-metals. We know that noble gases like helium, neon, argon, krypton, radon, they never take part in chemical reactions. They do not take part in chemical reactions. But the other elements, they participate in chemical reactions, metals as well as non-metals. What is the driving force behind a reaction? The driving force behind a reaction is to attain the electronic configuration of the nearest noble gas with complete octet. Complete octet means the last orbit should have 8 electrons in it. Now, how does a metal form the nearest electronic configuration of noble gas? We can see this with the help of this reaction. Sodium is a metal. It loses one electron and it forms sodium ion. And what is the electronic configuration of sodium ion? It is 2,8, which is the electronic configuration of neon, which is an inert gas. So what does sodium do? It tries to acquire the electronic configuration of the nearest inert gas, that is neon, and it forms a positively charged ion. Now in the case of chlorine, chlorine is a non-metal and it is taking electrons. It is receiving electrons. You can see it is receiving electron, and its electrons, you can see there are 7 electrons in the outermost orbit. And it requires one more electron to form an octet. So it gains an electron from metal, it can be sodium, and it completes its octet. You can see that the octet is completed here. And there are now 8 electrons in the last orbit. The last orbit has now 8 electrons. And the electronic configuration of chloride ion is that of argon. The nearest inert gas, argon. Chloride ion has got a negative charge. Now sodium ion has a positive charge and chloride ion has got a negative charge. So sodium, it is losing one electron, it loses an electron to chlorine. Chlorine accepts that electron. You can see it is accepting that electron. Okay, and it forms a chloride ion which is negatively charged. Now because they are oppositely charged due to electrostatic force, due to the electrostatic force of attraction, these two ions, they are attracted towards each other, and the bond that is formed between them is an ionic bond. So basically you can say the driving force is to form the electronic configuration of the nearest noble gas. That's the reason why reactions take place.